And welcome back. In this video we'll continue with computing limits, and this time we'll learn how to compute limit as x tends to 0 for radical x power 2 plus 100 minus 10 over x power 2. So we'll start as usual by replacing x by 0 in this case, and I'll get radical 0 square plus 100 minus 10 over 0 square, and this will give radical 100 which is equal to 10 minus 10 over 0, and this will give 0 over 0. And as usual, 0 over 0 is indeterminate form, so it's an IDF case, which means that we need to go and figure out a different method to compute this limit. And so one of the methods that I can use here is to try to multiply by the conjugate, in which I'm going to multiply by radical x power 2 plus 100 plus 10 divided by radical x power 2 plus 100 plus 10. And as you see, this quantity will not change the value because it's equivalent to 1. Because we know that whenever you multiply by a and divide by a, this means that you're multiplying by 1. And multiplying by 1 will never change the quantity. Then after that, we need to know or to have an idea why I'm doing this. The reason came from the fact that a minus b into a plus b, if we expand these two products, or these two factors, this will give a power 2 minus b power 2. And we know that power 2 can cancel radical. For this reason, what's happening here, I'm seeing this as a minus b, and the second as a plus b, in which, as if I'm taking a to be radical x power 2 plus 100, and b as 10. Then if I try to expand the numerator, this what will happen. I'll get limit as x tends to 0 for x power 2 plus 100, because it's a square, so I'll lose the radical, minus 10 to the power 2, which is 100, divided by the denominator, which is x power 2 into radical x power 2 plus 100 plus 10. So yeah, plus 10. Then after that, 100 and 100 will cancel out, and I will left with x squared in the numerator, so over x power 2 radical x power 2 plus 100 plus 10. Okay, then again I can cancel x power 2 with x power 2, and I'm left with 1 in the numerator. As you see, x power 2 over x power 2 was the main reason of having, or the reason of having 0 over 0. And after canceling it, I can go now and replace x by 0 and check the result. So I will get now 1 over radical 0 square plus 100, so this will give radical 100 plus 10, and of course radical 100, since 100 is a perfect square and it's equal to 10 power 2, so this will give 1 over 10 plus 10, so this will give 1 over 20.